Welcome back to my channel. Today I am going to be talking on the topic asymptotic notations in digital analysis of algorithms. So let's see. So let's know what it is first. So asymptotic notations in analysis and design of algorithms, or what you call as DA now or ADA, is it helps in analyze the efficiency of a given algorithm. Efficiency can be considered in the aspects of time, space, and many other manners. So, of these, to represent whether they take a lot of time or average or less, you use the asymptotic notations. So, they provide a way to describe the behavior of algorithms as the input size approaches infinity. So, commonly used asymptotic notations include big O, big omega, and big theta. Here on the left you can see the diagrams for the different ones. The first one being the big theta, the second one being big omega, and the second one being big O, and the third one being big omega. So here, if you see the diagram here, so the top line here and the bottom line, these two represent the higher and the lower values, and the middle line represents the function. And the point you see here, that is the NO or K that is given here, it says until that point it may be varying, but once you cross that point, the higher value is always greater than the function and the lower value is always lower than the function. In big O, same way NO, before that it is varying, but after that in big O, the value is always greater than the function. And in big omega, it's always lesser than the function. Same manner. So let's see. The big O notation represents the worst case scenario of an algorithm's time complexity. It provides an upper bound on the growth rate function. For example, big O of n denotes the linear time complexity. So you might be thinking, what is this growth rate function? So it goes like this. You have 1, you have log n, you have n log n, n to the n square, n cube, 2 to the power of n to the power of n, and it goes on. So that is the value where n is your average case. Before n, that is 1 and log n is your lower bound, and after that is all your upper bound. In omega notation, it represents the best case scenario on an algorithm's time complexity. It provides a lower bound on the growth rate of a function. For example, the omega n here, omega of n, denotes the linear time complexity. In theta notation, it represents the average case scenario of an algorithm's time complexity. It provides both upper bound and lower bound on the growth rate of a function. For example, here, as you see, theta of n denotes the linear time complexity. You can see in this here, which is the worst case, best case, and the average case. Now, comparing asymptotic notations. Big O, omega, and theta notations are used to analyze different aspects of an algorithm's performance. So, the big O is most commonly used notation for analyzing algorithms. Understanding the difference between notations is essential for accurately analyzing algorithm efficiency. The importance of asymptotic notations. Asymptotic notations help in comparing and evaluating algorithms based on their efficiencies. They provide a standardized way to communicate the performance characteristics of an algorithm. By using asymptotic notations, the developers can make in or can inform the decisions about an algorithm's selections and optimizations to the user or anyone else. Now, practical applications in algorithm and design that you see, the practical applications of this. So, the asymptotic notations play a crucial role in designing and optimizing algorithms. They help in identifying the bottlenecks and optimizing critical sections of the code. By analyzing the time complexity of an algorithm, developers can improve the performance and scalability. Just to make it clear, these are not only used on time complexity, they can be used in many ways. One being the space complexity also, that is how much of space it takes. So it can do both. Actually, there are many ways to scale the performance of a computer. Here we are taking the time complexity as a feature or a main one to scale the big O or big omega or to compare. Now, limitations of asymptotic notations. So, asymptotic notations provide a high level analysis and may not capture all details of an algorithm's performance. They do not account for the constant factors and lower according to the lower order of the terms which can impact the real world performance. It is essential to complement asymptotic analysis with empirical testing and profiling for comprehensive evaluations. So, in summary, asymptotic notations are an essential tool for analyzing algorithm efficiency and its performance. The big O, omega, and theta notations provide different perspectives on the growth rate of a function. Understanding and applying asymptotic notations can help in designing efficient algorithms and improving software performance. In the next video, I'll be telling you how to cope up with the limitations of an algorithmic power or the algorithms. Hope you understood something from this video. Thank you.